Now we look at this question still under collisions, and here in particular inelastic collision. I've been talking about collision for some time now, and I mentioned two types of collision, elastic and inelastic. And for these two types of collision, their total momentum, momentum of a system of colliding bodies is constant. No change of momentum, just a transfer of momentum between the two bodies. And they also said that for elastic collision, both momentum and kinetic energy are conserved. And in my last video, I derived two equations you can use to determine the unknown velocities of the two bodies after the impact. Because for the first type of momentum, for the first type of collision, which is elastic, the two bodies go their separate ways after collision. It is a rebound from each other, or so to speak, after the impact. For the case of inelastic collision, when the two bodies collide, they stick to each other, they form a composite body, and they move together with a common velocity, with common speed in a particular direction. We call that inelastic collision. So that's how to identify collision that is inelastic in this case now. They stick to each other. And then here we say kinetic energy is not conserved, so their total momentum is still conserved. And also the total energy is conserved. Why is the kinetic energy not conserved? Because part of the initial Ke is converted to sound or heat or elastic potential energy, which causes the deformation in the case where there is deformation of the two bodies deformed after the impact. So here we are going to look at a question that will help us to understand better this inelastic collision. A trolley of mass 2 kg moving with a velocity of 2.5 meter per second collides with another trolley of mass 3 kg moving at this velocity 1 meter per second in the opposite direction. And then the two masses or two trolleys stick to each other. Now we have to calculate their common velocity, the initial Ke, that's their total initial Ke, their final Ke, and then the loss of Ke, and then we want to make a comment on our answer. So how do we start? Let's just get a picture of what is happening there. Here is the first trolley moving with a speed of 2 meters per second in this direction along the positive x-axis. The mass is 2 kg. And I have the second trolley moving with a speed of 1 meter per second towards the negative x-axis. The mass is 3 kg. Now this is situation before the impact, before they collided. So after the collision, the two trolleys, let's say there's means of providing a glue so that after the impact, they glue to each other and they move off in one direction. We don't know whether they move together to the right or they move together to the left, okay, with a common velocity v. So let's call this one m1, let's call this one m2. The initial velocity of this first trolley, let me call that trolley 1, let's call that u1. The initial velocity of this trolley 2, I call that u2. Of course, my u2 is 1 meter per second. So after the impact, this is see my m1 and m2, and see how they move. Let's assume they move in this direction along the positive x-axis. Okay, so now with using the principle of conservation of momentum, total momentum before collision must equal their total momentum after the collision. So before collision, we have m1 u1 plus m2. I'm going to assign direction now. My direction to the right, I give that positive, that is along the positive x-axis, and going towards the negative x-axis, I give it negative, so that my u2 is negative minus this is equal to my m1 v1 plus m2 v2. Now this becomes m1 u1 minus m2 u2 is equal to, now in this case, the final velocity of the first trolley v1 is equal to the final velocity of the second trolley v2, because the two bodies stick to each other and they move off with a common velocity. It means this common velocity v equals v1 is also equal to v2. Okay, so I say this is v1 equal to v2 equals v, meaning that I'm going to replace v1 with v and replace v2 with v. So factoring out that I have v into m1 plus m2 is equal to the sum of their initial momentum, m1 u1 minus m2 u2. Okay. Then finally, I'm going to divide both sides by m1 plus m2 to have the expression for my common velocity, which is divided by m1 plus m2. Okay, with this I can now substitute my values. What's my M1? What's my U1? And so on. So let me move to this page. I have my V is equal to my M1 is what? 2 kg. What's my U1? 2.5 minus my M2 3 kg times my U2 1.0 over the sum of the mass is 2 plus 5. So that gives me 2 times that 5 minus 3 over 7. Okay, that gives me 2 plus 3, not 2 plus 5, please. So that gives me 5. Okay, so this gives me 2 over 5, which results in 0.4 meters per second. So the two trolleys, after the collision, move off together with a common speed of 0.4 meters per second. Okay, we solve the second question, which says we should calculate their total initial kinetic energy. What's the initial kinetic energy of the system of colliding bodies of the two trolleys? Kinetic energy, because kinetic energy is a scalar quantity, so it doesn't matter the direction they were initially moving. Their total K, let's call that total initial K, EK1. Let's say this is KE of the first trolley, E1 plus the K of the second trolley before they made the head-on collision. So my E1 is half M1 U1 squared. My E2 is half M2 U2 squared. Okay. So my total initial KE, EK1 becomes half times M1 is 2, U1 is 2.5 squared, plus don't forget to put that, apply the square. So my students, when they solve analysis, they always forget to include the square sign, the square there, that is multiplied by 3 times 1.0 squared. So that gives me 2, cancel these two. 2.5 squared gives me 6.25. Can confirm that. Plus this times this, 1 square gives me 1. Half of this gives me 1.5. So my total initial K of the two trolleys is going to be 1.5, 0 plus this, that gives me 7.75 joule. Okay, now let's see the kinetic energy of the two trolleys after the impact. After the collision, what is their total final kinetic energy? Kinetic energy, final Ka. Okay, now in this case, the two trolleys, because they stick to each other like this, and they move on with a common speed v. It means that these two masses are become one, and then their Ke is now, let's call that Ek2, final Ke of the two masses, two trolleys, becomes the total mass m1 plus m2 times the common speed squared. Okay, not to forget to square that. Now this gives me half times the total mass is 5. Their common speed, we calculated that as 0.4 squared, 0.4. So that will give me 2.5, that is half of 5 times 0.4 squared. Okay, so if you have your machine here, you can, that gives me 0.4 joule. So let's compare these two energies. The total initial Ke of the two trolleys was 7.15 joules before the impact. Now, after the impact, their total Ke is just 0.4. There's a loss of kinetic energy. That leads me to the fourth question. Kinetic energy loss is 7.75 minus 0.4. So see that a great deal of the kinetic energy is lost. What do you think should be responsible for that loss of Ke? Now recall that from the principle of energy conservation, energy can neither be created nor be destroyed. It's only being converted from one form to another, meaning that the loss of Ke must appear in another form of energy. I'm sure you have seen two vehicles or thereabout making this head-on collision. You usually hear a loud bang sound. That sound energy is converted from the loss of Ke, from the Ke that is lost. Part of it is changed to the sound energy, and sometimes heat is produced, and sometimes there is a deformation of the bodies involved in the collision. Energy is needed to deform a body. So that is also taken from the part of the Ke that is lost. And no matter what happens, nevertheless, the total energy of the system must remain constant. So the loss of Ke must be equal to the other forms of energy, heat energy, sound energy, or elastic potential energy that is converted to, so that energy is eventually conserved. So that's a question on the inelastic collision.